Hello all, my name is Sarah Webber. I'm excited to have had the opportunity to work with Ilyena Hirskyj-Douglas on this paper, in which we reflect on methods in ACI, the novelty effect and habituation. So there's lots of interest in how technology can enrich animals' lives by providing with new behavioural opportunities, increasing choice, the range of sensory stimuli, or creating new channels for positive interaction and communication with humans. However, in many cases, animals' engagement with digital technologies is short-lived unless there are food rewards or some sort of extrinsic reinforcement. Often we see initial high levels of interaction followed by little use or no use at all. It's important for designers to understand how an intervention's value to an animal user might change over time. And in this paper, we examine two phenomena, habituation and the novelty effect, which can help us understand these patterns of use over time. And we consider what they mean for ACI design and evaluation. Animal behaviour and cognition researchers have studied animals' patterns of engagement with new stimuli, including enrichment, in zoos, for example. And it's widely understood that enrichment objects lose their appeal over time due to habituation. Habituation has been defined as a decrease in responsiveness to a stimulus when that stimulus is presented repeatedly or for a prolonged time. Now, we can note that habituation is an essential learning process. It allows animals, including humans, to pay attention to new and potentially dangerous stimuli, but avoid expending energy and time on unnecessary responses to stimuli which have been encountered previously. So habituation is also desirable in some circumstances as part of ACI work. For example, if we want an animal to wear a muzzle or get used to the noise of a drone, something that could be scary or unpleasant at first, then we want habituation or gradual desensitization to take place. Evaluations of enrichment for zoo animals have shown that habituation can be slowed down by the way it's provided. So a study of sloth bears, for example, interacted with logs filled with honey more when it was presented intermittently rather than being available all the time. Habituation doesn't occur so fast if there's intermittent presentation. And all the more so if the enrichment is provided on a variable schedule rather than predictably, say every other day. It can also be that withholding enrichment for some period of time after an animal has lost interest can result in what they call spontaneous recovery or renewed interest when it's presented again. And the novelty effect can create similar patterns in usage, high levels of interaction at first, followed by a drop-off over time. And this has been seen in studies of people's use of novel systems. Say and all define the novelty effect as the human tendency for heightened engagement and or performance when encountering the introduction of a novel phenomenon, such as the introduction of a new technology. Subsequently, user interest and engagement may gradually disappear. So the novelty effect has been reported in people's use of a range of technologies, including things like activity trackers, public displays in workplaces and in public settings, and in things like gamified learning. The novelty period has been reported to last about 3 months, give or take, but some people have suggested it could well last up to 6 months. So these studies have found that when a system was changed or updated, it generated renewed interest. The magnitude of the changes and the frequency of the change affect the extent to which people re-engage with the technology after a period of habituation or the novelty effect wearing off. For humans, the patterns of use over time are affected also by trends and social pressures, of course, as well as the need for instrumental use of tools. If I need to use new technology to do my job or to pay the bills, then I'm going to use it. But there seem to be some overlaps in the findings from studies of habituation in animals' use of enrichment, say, and the novelty effect in human-computer interaction. And it seems there might be some parallels in the way that these phenomena can be addressed by designers. An ongoing challenge for ACI researchers and designers is to define robust evaluation protocols to ensure our interventions are having beneficial impacts in the long run. Short duration evaluations are often conducted, and these are valuable to ensure feasibility and usability of a prototype, check for potential unintended impacts in terms of animal welfare, and to get the animal's input into the design process. But assessing animals' long-term subjective experience of using technology is more challenging. One proposal is that to assess animals' interest in or liking for a technology intervention or another stimulus, We can observe their choices if they choose to interact when they have the choice between alternatives. However, we should be aware that animals' use of an intervention might be motivated by something other than preference. For example, fear, behavioral instinct, compulsion, or stereotypies. To look at the novelty effect and habituation in ACI interventions for enrichment, we analysed and compared data sets showing use of 3 digital interventions by 3 species over time. Kinecting with orangutans is an interactive projection system. It's designed to provide visual and cognitive enrichment for orangutans, and the animals can interact with applications by touching the projection surface with hands, feet, other body parts, or objects. Here we have data from animals' interactions with 5 proof of concept applications. They aim to show the functionality of the device and capture animals' interactional preferences. So we note that the animals had had prior exposure to an earlier prototype about 1 year prior to this study, and data of those interactions is not included here. We can see patterns of use by 5 orangutans over the course of 4 or 5 sessions, each several days apart. Trials were conducted with the animals individually at a consistent time of day and lasted 1 hour. The pattern of use is pretty consistent across the orangutans, although a couple barely use the system at all. 4 of these orangutans are adults and 1 is a juvenile. Can you guess which is the juvenile? 03, the one with that renewed interest in session 4 and overall higher levels of usage. Now, there's no obvious explanation for that spike that we see on session 4 in 03. We can speculate it might be due to social factors, visitor numbers, or visitor behaviour, but not knowing prompts some ideas about additional data that we might have collected during this study to help us answer questions like that. Video data, for example. Doggy vision is an audio-visual system which can be switched on and off by dogs. So it recognises when a dog is in front of a screen and then plays one of a playlist of media clips showing a range of dogs in different situations. When the dog left the interactive area, the screen would become blank. And the Doggy vision system was used with 2 dogs individually in their homes. Prior to being switched on, the system was placed in the home and collected baseline data about the dog's everyday behaviours. The system was switched on during the 2nd week and dogs had constant access to the system. The system captured usage and duration of interaction. And we can see from the counts of dogs' interactions and total usage duration that dog 2 interacted more frequently than dog 1, and that might have been due to differences in age and overall activity levels. One question that remains here is whether the dogs had in fact learned how to use the system after day 7. The Saki tunnel intervention provided Saki monkeys, 7 of them, with a tunnel-shaped device which was placed in their indoor zoo enclosure for several weeks. Proximity sensors would detect the presence of a Saki in the tunnel and would trigger playing a video. Every 7 days, the video would change. In total, 5 video clips were offered, and they were highly varied in terms of colour and movement. Interactions were logged and recorded by video, but it's collected at the troop level, not the individual level. We note that the Sakis had previous experience of the system providing audio enrichment, and the usage data for that intervention is not shown here. Here we can see Saki's interaction count and total time spent interacting with the Saki tunnel. And the peaks and troughs in interaction could indicate that some stimuli were preferred to others, or these patterns might be due to habituation and spontaneous recovery. Extraneous factors are likely to be at play on days where outlier data points are seen, so interaction counts on day 11 and 22, for example. Nonetheless, even with those varied stimuli, the Saki's interactions with the Saki tunnel decrease noticeably after day 15. So let's discuss now the implications for design, deployment, and evaluation. Usage data from these studies indicate that usage patterns can differ quite substantially between individuals within species. It seems that personality and individual preferences might play a factor in interaction styles and also in the effects of novelty and habituation, creating additional complexity for designers of digital enrichment. Designers should also pay attention to salience, the extent to which a stimulus is different from the animal's existing environment and experience. Using objects which are familiar to animals, such as tugs and ball toys in digital interventions, might result in faster habituation than to novel physical components. It's possible that varying the physical stimuli associated with a digital intervention might counter habituation. We note that in our data, it's hard to disentangle the interest in the physical installation, such as the plastic tunnel provided to Sakis, from the digital media offered. Also important are considerations about the way it's deployed, for example, the frequency and duration of presentation, whether it will be continuously available or withheld and on what schedule, and the extent to which digital media or other components are varied over time. For researchers conducting co-design with animals, it might be tempting to see an animal's early enthusiastic engagement with a novel device as an indication that it's well designed for the species, or that the animal likes the intervention. But our analysis indicates that early high levels of interaction can diminish substantially, so evaluation over a period of weeks or months is generally needed to draw conclusions about the long-term value of a proposed intervention. ACI designers will note that there's a tension between extended duration evaluations and rapid iterative prototyping cycles that are favoured by interaction designers. Short-term evaluation of prototypes is important to gain insights into usability, ergonomics, learnability, and the mechanism of interaction. But there's likely an impact of these early exposures on the patterns of long-term use and habituation. So we need more data to understand how habituation to an early prototype is likely to affect animals' interactions with subsequent prototypes. To better understand habituation to digital and interactive interventions, there's a need for researchers to capture not only interaction counts, but also the duration of each interaction. To better understand the effect of variation and withholding the intervention, as often happens between prototyping cycles, we need more data about the timings of these deployments and variations. Changes to digital media and other features of a prototype can mean spontaneous recovery to some extent. And we propose for our field to better understand how habituation is affected by deployment choices and system changes. ACI researchers should report the types of stimuli, the way that variants are introduced and rate of change, and ideally provide exemplars of content as supplementary material to publications. This will provide richer data for us to understand how interactivity and digital variation can interact with habituation, generalization, spontaneous recovery, and dishabituation. So this analysis also prompts some important questions about how to best evaluate ACI interventions and can provide new perspectives on this question. Let's talk about usage counts first, a common metric and one we've used in these 3 studies, of course, and they're helpful, although they have limitations. Usage counts can help us determine that a system is being used to some extent, and that's often a prerequisite to effectiveness. If the aim of an intervention is to provide an animal with new behavioural and sensory opportunities, then it's certainly useful to look at the frequency, duration, and quality of interactions. But it's clear that usage per se doesn't equate to usefulness. Exploration and novelty might result in high levels of use initially, even if the intervention ultimately has no value to the animal. So we need to also think about other measures which might be more appropriate for evaluating effectiveness of enrichment. For example, counting instances of positive animal behaviours, such as playing or positive social interactions with other animals, versus behaviour that indicate negative welfare, such as pacing. So this is a technique that animal behaviour and welfare sciences often use to evaluate an intervention. And these can be supplemented, of course, with physiological measures, such as the presence of stress hormones in saliva, hair, or feces. And of course, this isn't straightforward because an animal's stress levels might be affected by the presence of a new intervention in some cases, regardless of its usefulness. And this effect might abate over time with habituation. Given we can expect a drop-off in levels of interest in an intervention, we need to think about the effectiveness in the medium to long term and avoid making unsubstantiated conclusions on the basis of short-term studies. An intervention which is in some way familiar to animals or similar to devices or objects they've used will be easier for them to learn to use. And in some interventions, learnability is an important consideration. However, if we want to promote ongoing engagement, we might consider devices which are very different from animals' prior experiences. Habituation is likely to be slower. An important consideration here is that we need to be clear about the purpose of an enrichment intervention, the form of enrichment we want to offer, define what success would look like, not just in the initial trials, but over time. And this can guide us towards some important trade-offs in terms of addressing habituation in design choices. To understand what engagement will look like after a period of habituation, we need to offer the device on multiple occasions over an extended period. The burning question then is, how long does that take? Well, there's no clear-cut answer to that. And one issue is that we currently don't have enough data to answer the question. What's clear is that with longer duration studies, we will have an opportunity to examine and measure habituation. And this is important to effectively evaluate our design choices. And it will also give us, as a discipline, more of an idea about how habituation occurs with interactive and variable digital technologies. It's worth noting here, this is another area where there's plenty of research in the fields of animal behavior and comparative cognition. And ACI researchers can make use of that by collaborating with specialists from other disciplines. An opportunity that comes here from the ability to automatically capture data about how animals use technology. So this could minimize time-consuming observation by researchers or animal carers. And we propose that digital interventions should automatically log interactions, the frequency, timing, duration, and also capture video of animals' interactions, and where possible, of the wider context. This multimodal data can provide insights into the impacts of the intervention from multiple perspectives, and provide valuable clues to other factors that might be interacting animals' patterns of use. That sort of data can be used to glean more insights into how habituation takes place over time and how it's affected by choices about design, variation, and deployment. So overall, we argue that ACI researchers need to attend to the novelty effect and habituation in design, deployment, and evaluation of interventions for animal use. It draws attention to the need for long-term ACI evaluation and opportunities to plan data collection so as to build collective knowledge about how animals habituate to digital technologies. This is relevant because those digital technologies can be varied over time and they can contain physical and digital components. This will help provide a foundation for more effective design that benefits animals and refine how we can conduct interaction design with animals. Thanks everybody for listening. We welcome your questions.